Section 1.5, algebraic properties of limits and piecewise functions. So he said, these are the video notes from what you watched. Back in the day, if you've got a couple x's, you combine them together. Kind of the same thing goes with limits. If I have two limits that I'm trying to add together, as long as they're both the same function, f of x, you have two of them. So if I add the limit of this function plus the limit of that function, I have two of that same limit. Then he went into some explanations here using the table, and he gave you some examples. If you were to plug a 1 into here, then you'd be looking at a negative 1, and that's just changing up what this value is down here. It changes up what x you're approaching. So as you plug in the 1 into this, it means it's really taking the limit as x approaches negative 1 for f of x. And so that's where the kind of confusing part comes in. But same with this one. If I take a 1 and plug it in my g of 1, well, g of 1 is this guy. That's 6. So this would be the limit, which would be 6 over 2, and that gives you a value of 3. When you add them, you get 5. These are all composite functions. They're called composite functions. Remember when we fogged and goffed? That's what this is. This is fogging and goffing, but with limits. So it changes things up, and what it changes again is what this x is approaching based off of what you're looking at. So you want to put a 4 in here. You've got f of 4. If I look at 4, I get a 1. F of 4 is 1. So that means that changes this from being a 4 down here that x is approaching to being a 1 that it's approaching, because f of 4 is 1. And then it's for the f of x function, because this is still an f here. And so if I approach 1 for this function, if I approach 1, I'm over here, that's going to be a value of negative 1, and that's what your answer is. So again, what changes is you plug in the 4, that gives you a new x value. That x value is the one that the limit is now approaching. And then you do the same thing down here. He gave you another set of values. You're plugging in h of x is 5, and you're plugging in all your values from your chart up here. When you simplify it out, you get 17. And then he actually gave you some piecewise functions, and he said, okay, if I have a piecewise function and I'm coming at negative 5 from the left, well, if you're coming at it from the left, then you're less than what it is. So that would be this piece here. So you're plugging your 5, negative 5, into the part that's less than negative 5, because you're coming from the left. And that gives you a value out of the square root of 16, which is 4. Which, by the way, did anybody question or have it like, how come it's not plus or minus? Anybody think that? Okay, well, maybe just I thought it. Anyway, when you take the square root of 16, normally it's plus or minus those things. But funny enough, in calculus, they just consider really the positive part of it. What's the square root of 16? It's 4. They kind of, yeah. Did you think that too, Genevieve? Thank you. Yeah, why are they not doing plus or minus? And it's kind of, I want to say it's big boy math, you know? Like when they get into this level, they just take the plus side of it. Kind of weird, but true. Yeah, so when you see square roots, pretty much from now on, you're just going to take the plus part of it, not the minus. There would be two values. It would be plus or minus 4 for the x. Square root of 16 would be plus or minus 4. And yeah, maybe that's the part of it. Maybe you're right with that, Catherine, that it would no longer be considered a function if it were plus or minus, because then you'd have it failing the vertical line test, and you're right. So maybe that is kind of what they're thinking about with this. All right, anyway, that's A. B is 1/10, and C is does not exist for this one. And again, the reason why the C part doesn't exist is because these two numbers have to be the same. Remember, as you approach negative 5 from the left and negative 5 from the right, they have to be the same number in order for the actual limit to exist. So that's why C's doesn't exist. Same thing goes over here. If I approach negative 1, if I'm approaching negative 1, I am taking I want to come back to that because I have a feeling that there was a practice problem that came into play with this guy. If I'm approaching -1, see how this inequality doesn't equal -1? And this inequality doesn't equal -1? That means that these two things have to be equal to one another. So if I were to look at those two things, let's see if that is the case. We know what it is here, it would be a 3. So if I put a -1 in here, 10 minus 1 is 9, square root of 9 is 3. If I put a -1 in here, let's see what happens. I have 26 minus 5, which is 21, and 21 over 7 is 3. That's why this guy's 3. You have to check it both ways, and I don't know that he showed that work for that. But it has to approach the same y value from the left and from the right, and they both approach 3, so the answer is 3. But I don't think he showed you the second part of that. For e to the right, well, to the right of e would be greater than, so it's the ln of e to the third. If you remember your ln rules when you do the loop, that means it equals 3. And then what is the actual limit at e? And that would be this guy here, because it's equal to, so you just plug it into this guy, and you end up with a, actually you end up with, so you're going from the left is going to be this guy, that's the work here, and then from the right is going to be this guy, that's 3. These two things are not equal to one another, so you end up with it doesn't exist on that one.
I think he did show that in the video about
Did he?
how, like, for the,
This guy?
I'm pretty sure
Okay.
how the C part of it is only from, wait, I wrote it down. Did I write it down here? Oh yeah, I wrote it down in notes, how it's like, it's from the left, so the left and the right aren't the same.
Did he talk about that? Cool. All right. Good. All right, so then what I want to do is I want to do some of these practice problems with you. So I picked a few from your practice. Here they are. So the first one I want to do is number 2, part A and B. So we're going to do all of number 2. Let me see if I can line it up so you can see it. So these are those ones that are slightly confusing. I'm replacing my x with the x they give me, and then I'm going to see where that lands me. So if I put a 2 in here, that means I'm looking at f of 4 as x approaches 4. So it changes this. This is now the limit as x approaches. If this is f of 4, then I'm going to look at this guy here. See how it's approaching 4? 4 of f of x. And then I'm going to subtract that with the limit as x approaches. Plug a 2 in to this. 2 over 2 is 1. So now I am approaching 1 of f of x. Did you catch that? And then I can go to the chart and figure out what the numbers are. So if I look at the limit as x approaches 4, that's 2. The limit as x approaches 1 is 6. And 2 minus 6 is a -4, and that's my final answer. All right, try B. We're going to try B. Do you want to try B and see if we match? Why don't you try B and I try B, and we'll see if we get the same thing. Okay, so for B, you should have, if you place a 2 in here, you got f of 1. That's your new, what you're approaching. If you place a 2 in here, now it's -2. That's what you're approaching. Go to your table. As x approaches 1 for this function, you get 6. As x approaches -2, you get -3. And when you divide them, you get -2. All right, that's the first kind from a table. The second kind is like number 4. And number 4, this one I want to look at, instead of them giving you the table values, they're giving you the picture of what the graph looks like. So this time I'm going to take a -2 and put it in here. If I put a -2, I've got to think about what the coordinate is. So the coordinate at -2, here's my like -2, here's 1. That's what the coordinate is at -2. So I'm looking at, for this one, the limit as x approaches, and what happens is you're going to use whatever this value is, just like you did in the chart, right? The chart gave you what those f of x values were. So this is going to be the limit as x approaches 1 for f of x. So it goes by what, yeah, this is the -2. So it goes by whatever that y value is. So if I go to the limit as x approaches 1, now I'm over here. So I'm looking at what the limit is here. The limit to the left goes to -1. There is no limit from the right. It doesn't even connect down to where 1 would be. So this one is a doesn't exist. And the second part's asking the same kind of thing. I look at the coordinate. If I'm at 4, x of 4, I'm a y of 3. That's my coordinate. And so that changes up my limit. Now my limit is as x approaches 3 for this function. All right, so let me go to 3. Here's 3. From the left it's 2, from the right it's 2, so my answer is 2. Okay, we are flipping to the next page, and I want to look, oh, hold on, I'm falling apart. You should see this setup I got going on here. I have a stapler and a bunch of books that are holding my iPad on my desk. It's a disaster waiting to happen. And it just fell, so, okay. Hang on. All right. Whew, okay. Next one I want to look at is 6b. They give you another chart type thing, and you're looking at f of -2. So I go to f of -2, well that's a 7. And it's kind of like it's being multiplied in here. So f of -2 is a 7. And it's being multiplied by, I'm going to use brackets, the limit as x approaches -2 of g of x. So I go up here, the limit as x approaches -2 of g of x, that's this guy. Well, this limit is equal to -1. So that's what's going in my parentheses here. That's this guy. Then I have a subtraction sign. That's this guy. Then I have the limit as x approaches -2 of h of x. Well, the limit as x approaches -2 of h of x is a -3. Parentheses are going to be your friend in this situation because you're going to have to remember to distribute that negative. So what I really have is 7 times -1 plus 3, which is 2, and that gives me 14. Okay, and then the last one I want to do from this section is number 10, one of the piecewise things. So I'm looking at this guy, and I want to know what, if I look through all of the problems, like look through, kind of skim them, obviously these last two are coordinates. So maybe you might want to start with those because they're going to be different than what the limit problems are. So the coordinate is, what's the coordinate at -2? So you come up here to -2, you're picking the one that's equal to, because now you're looking at a coordinate, not a limit. So this one is the equation for equal to, and so if I do that equation that goes with the equal to -2, it's going to be 2 to the -2, because that's the equation for this value. Now 2 to the negative 2 would be like 1 over 2 squared, or the same thing as 1/4. Negative exponents go in the denominator, yada yada. F of 0 is also a coordinate, so I go over here, I look where it's equal to, and use that formula. So this guy would be 0 squared minus 4, gives me a negative 4. All right, then I'm going to go back. The rest of these are all limits. Now, if I look at, skim over, this one's the limit at negative 2, which means I have to check it to the left and to the right. Make sure it's approaching the same y value. But B is actually asking you what it is from the left and what it is from the right for C. So I might as well do B and C first, see if they match, and then I can answer A. Make sense? So I'm going to have to check them anyway. So if I come at negative 2 from the left, well, if I'm at negative 2 on a number line, and I'm left of it, that means all my values are less than negative 2. So this is the formula that I have to use. So I'm doing a direct substitution. 1 over negative 2 plus 6 gives me a 1/4. That's from the left. If I'm at from the right, then they're all values that are greater than negative 2. That means I'm using this guy. He's a 2 to the x. So now I'm over here, 2 to the x. Well, what am I putting in for x? I'm putting in a negative 2. And so I get the same answer, 2 to the negative 2. We saw that down there with G is 1/4. And so since they match, my answer here is going to be 1/4. Same thing goes with D, E, and F. They're all talking about what you're doing to the left and to the right of 0. So here's the 0 itself, here's left, here's right. Might as well check out these guys first. If I plug a 0 in, let's say 0 to the left would be values less than. So that would be this equation here, 2 to the x. Well, my x is 0, 2 to the 0. What does 2 to the 0 equal? Do you remember that, one of the identities? You've got a value of 1. If I'm to the right of 0, then I'm using this final equation, x squared minus 4, 0 squared minus 4 gives me a negative 4. And that means because these guys don't match, left and right don't match, this doesn't exist. Anything from section 1.5? Okay. Then we're going to scooch over to 1.6. By the way, I know that I posted these 1.5 and 1.6 answers on our classroom page. I just did that yesterday. So the answers for 1.5 and 1.6 are on there. And like I said, I'll post 1.3, 1.4 when I get my first break of the day today. So 1.6, I kind of like this section because it's a lot of algebra involved. And so the deal is you're figuring out limits, but sometimes you might have to do algebraic manipulation to the equations to make them work. So the first thing you always want to do is direct substitution. If direct substitution gives you this indeterminate form, then you have to try something else. That's the whole idea of what he talked about. So direct substitution, -5. This kind of question's an interesting thing. There's nothing for you to plug an x into. It's just 6. Just 6. Answer is 6 no matter what. So that was this guy because there's no x in your equation there. This one, you try it, you get the indeterminate form, you factor out an x, and then try direct substitution, and it works. That's the algebraic manipulation that he's talking about. Same thing goes for number 4. You end up with a 0 denominator. If you factor, things cancel out, and you end up being able to evaluate it, so you get -15. If you get something like number 5, same thing, direct substitution doesn't take you anywhere, neither does factoring. So there's nothing that you can do for this. This is the one where the limit doesn't exist. Was that the one, was that in Mean Girls? The limit does not exist. Yes, okay, there you go. Then he talked some identities. So the identities, these are things that were rules that we're going to have to remember. And what you want to do is be able to manipulate the equations they give you into this kind of a form so that you can evaluate it and get an answer of 1 or 0 depending on what the function is. So we kind of showed you that in number 6, 7, and 8. Number 6, it's a 3x, not just an x. So you have to compensate for that by multiplying by 3 over 3. That's a valid math move because that's really equal to 1. And so then you can move the 3 over here. Now it's the sine of 3x over 3x. That's what your rule says up here. So that equals 1. 1 times 3 is 3. He kind of did that quickly with number 7. Same idea, you have to multiply the top and the bottom by 7x and 9x. Because again, you can only manipulate it by something that's equal to 1. So it doesn't change the value of the function. So I multiplied by 7x on top and bottom, 9x on top and bottom, and then pulled things together so I can use the rule. Well, this part of it equals 1, this part of it equals 1. I'm left with 7x over 9x, and that gives me 7/9. And then he showed you one with factoring with number 8. Cancel, cancel. And then this is the rule, so my answer is 0. That was 1/6 video notes. Questions to there? Okay. Then we're going to look at pick and choose again some of the practice problems. So the first one, it just says evaluate each limit. The first one's number 3. Number 3, direct substitution is going to give me 1 minus 5 is negative 4 over 0. Well, that's not cool, right? Can't do that. So I'm going to take and think about what I can do to manipulate this so maybe I can make it prettier. And I can see I can factor an x out. So it's going to be, and you still want to keep this notation as you're going along. I know it's a pain in the neck, but Mr. AP likes to see that you've got the limit, you haven't forgotten it's still a limit. So it's x factored out gives me an x minus 5. On the bottom I have an x minus 1. Did that do me any good? No, no good. Nothing cancels out. And so if nothing cancels out, I can't algebraically manipulate it any further. So this one is it doesn't exist. This is one I can't make happy. I tried and I failed. All right, so then we go to number 9 is the next one I chose. And this one, you're going to have your factoring genes going for this guy. So I'm still taking the limit as x approaches negative 7. If I put in a negative 7, what happens? Let's see. I get 49 minus 49, and that's a 0 denominator. So pretty much it's the denominator that determines whether you've got something pretty that you can just directly substitute in or whether you don't. So checking it out, I end up with a 0 denominator. That means I got to try something else. The something else right now is factoring. So I'm looking at the top here. I can take an x out of all of those. Let me do that first. That's going to give me a 2x squared plus an 11x minus 21 all over. And in the bottom I can take out an x as well, x plus 7. All right, so far I can see my x's cancel out. I can forget about them now. And then I'm looking at this, and a lot of times this is the giveaway. This is like the hint that probably one of the groupings is going to be x plus 7 for the top. But you need to go through and factor that. Now back in the day of AC method, remember that from way back when? You take and multiply the first times the last. I'm going to go up here a little bit. I get negative 42. I need the factors of 42 that add up to be 11. Negative 42. The factors of negative 42 that add up to be 11. Anybody? It's 14 and 3. 14 negative 3, I mean. Yeah, 14 negative 3. I got you. All right, so If I do 14 and negative 3, then I'm going to divide by a positive 2, whatever the leading coefficient is. And that gives me my groupings. This guy's a 7 over 1. This guy's a negative 3 over 2. So here's my new statement. The limit as x approaches negative 7 for x plus 7 and 2x minus 3. Remember, you read those fractions bottom to top. And x plus 7. Whew, my x plus 7's cancel, as I expected. And now I'm left with the limit as x approaches negative 7, and I get of 2x minus 3. I've eliminated the fraction, and now I can just do direct substitution, take a negative 7 and plug it in. I end up with a negative 14 minus 3. And that gives me a negative 17, and that's my question, my answer for that guy. Okay. 15 is the next one I wanted to look at. (15), and if I look at this guy, my first thought is maybe to factor it. But are there factors that go to 10, multiply to 10, and add to a negative 4? And there's not, right? So then I'm looking at it, and I'm forgetting that what's the first rule you're supposed to do? What's the first thing you're supposed to try when it's a limit? Hopefully you're thinking direct substitution. That's what we're trying to do. So this one you didn't even need to factor. So you're going to get into such a factoring mode with all these problems up above. And then you're going to get to a problem like this where it's like, yo, direct substitution still works. So beware of that, which is the whole point of why I wanted to do number 15. So if I'm looking at this, if I plug a negative 2 in, negative 2 squared minus 4 times negative 2 minus 10 is all over a negative 2. And so I'm looking at this, I've got 4 plus 8 minus 10 over a negative 2. And I end up with 12 minus 10 is 2. 2 over negative 2 gives me a negative 1, and that's your answer for 15. All right. Let's try one last one, and then we'll summarize where we're at for the day and decide where we're going to go next. I'm looking to see which one I like better. 18's fine. Okay. If I'm looking at this one, do you see how it's not in the right order for factoring? It's backwards. You've got the x squared at the end rather than the x squared in the front. So the first thing that I wanted to do with this is change that around, because I know if I do direct substitution, by the way, I get 2 times 1/2, that's 1, 1 minus 1 is 0, so yeah, I know I'm going to have to use factoring or something to be able to make this work. So the limit approach is 1/2, but it's really a negative 2x squared minus x plus 1. All I'm doing is rearranging the terms. Now, I don't know how you feel, but whenever I try to factor, I ain't factoring something with a negative in the front, because that just messes everything up. So what I'm going to do is factor out that negative 1. So I get the negative that comes out. That gives me in parentheses a 2x squared. It's going to give me plus x minus 1. Remember, it changes all those signs. All over 2x minus 1. I'm getting closer. And then what I want to do is factor, forget about the negative for now, factor what's in my set of parentheses. So I'm going to go through the whole AC method and factor it out. Since we're slightly short on time, let me tell you what it is. Can you guess what you think is one of the groupings? Right? If I'm looking at the problem, probably one of the groupings is 2x minus 1, and it is. So I have a negative, I have a 2x minus 1. The other grouping that you'll get is x plus 1. And so now you're finally at a place where you've got common groups that you can cancel out. And then you've got direct substitution that you can do. So you've got the negative sign that's out here. I'm going to come over this way, negative. And then I'm plugging in a 1/2. So if I plug in a 1/2 plus 1 from this grouping, that gives me 1.5, 3/2, whatever you want to say, but it's negative. So you can either say -1 and 1/2 or -3/2. They are both the same thing. Okay, so let's summarize where we're at. We got through most of the examples on section 1.6. We did not finish everything that I wanted to do. There was a couple more problems, 3 more actually, that I'd like to do. So when we meet again, let's see, these Friday practice problems, 1 to 13, you should be fine with those because we finished 1.5. Monday's problems, I may make, let me say up to number, what did we just get to? So we'll say 1, I'm going to cancel this. You should be able to do 1 to 18. Those are going to be due for Monday. And then when we get together on Monday, I think what I want to do is finish these, obviously, and then start 1.7. That means you need to watch the video for 1.7. I'm not going to do 2 sections. We'll do 1 so that we have time to finish up 1.6 and we're not rushing too much. So you're going to watch the video for section 1.7 so that you can be ready for the notes that we go through pretty fast with that. So due for Friday is practice from 1.5, numbers 1 to 13. Due for Monday before class is 1 to 18 from 1.6. And then we'll start 1.7 on Monday as well. Does that put you in a good place? Okay, you're going to shoot me an email if you need me for anything. In the meantime, if you need extra help, I'm happy to meet with you. Just let me know and we'll set up a Zoom time together, okay? All right, have a good one.
Ms. Winter, I had one question I was curious about.
Yeah.
When we go back, like, are we going to be doing fire drills and stuff? Because that requires, like, huddling.
We are required to do, the state requires 2 drills a month for every school. So yes, we'll do some kind of drill, but maybe they might do more of the shelter in place kind of things where you're in your classroom anyway and you're not moving outside of the building. Yeah, I'm not sure. The state requires it, so I'm sure we're going to do it, but we'll probably do it in a COVID kind of way.
I was thinking, like, if we did a lockdown drill, we can't all go to the corner of the room.
Yeah, we're not doing that. I think we'll do a shelter, even if it were a lockdown, I think teachers are going to probably tell you to just stay where you're at.
Yeah, I don't know, just something my friend asked me about, and I wasn't sure.
Now,
I like never thought
yeah.
about it.
Yeah, I hadn't thought about that either, but you're right. Like I said, we have to do it, so we're going to probably do something, but don't know what it's going to look like. We'll see.
Have a good day.
You too. Have a good one.